Alright guys, let's get started with our last example for this module. It's going to be yummy, and it deals with the chocolate sales forecasting example. As always, let's get started by setting our directory to the folder where we've downloaded the chocolate dataset. Once this is done, we clean up the memory of our current R session, and we are ready to load our dataset with the read.table function and the usual arguments that we use. Now, to get familiar with our dataset, we use the str function, and we call it on the dataset that we've named data. What we find out is that we have 120 observations in this dataset and 4 variables, namely the time variable, which goes from 1 to 120, and which essentially means that we have 10 years of monthly data. Then the sales variable, which corresponds to sales in thousands of units. Then the year variable, which tells us the year of the particular data point. And the month variable, which tells us the month of the particular data point. Well, until now, we've always called the summary function on the entire dataset. It does not really make sense to have the mean value for the time, or for the year or the month variables. So what we're going to do here is to call the summary function only on sales by typing summary, open parenthesis, then data $sales, close parenthesis. And we find out that the minimum sale was about 37,000 units. The maximum was over 1 million units. And on average, 216,000 units were sold. Let's plot the sales as a function of time to get a better intuition of our data. To do so, we use the plot function. Time goes first because it will be on the horizontal axis, and sales second because it will be on the vertical axis. Then we add a main title with the main argument, and axis labels with X lab and Y lab. And we use the ylim argument in order to set a specific limit to the Y axis wider than the default, so we multiply the maximum value of sales by 1.2. And our last argument here is the type of plotting that we want to do, and we set it equal to L in quotes, which is lines. Let's run the line. What do we see? We see that the data shows seasonality, and most importantly that this seasonality is regular over time. It looks like there is a peak somewhere around, let's say, the 12 months. And here again, it looks like it could be month 24, and so on and so on. Now, as you did in the lecture, let's build a simple linear regression model with the sales as the dependent variable and month as the independent variable, and then the data that we use to build the model is our dataset, which is called data. If we check the output of the model, what do we see? We find out that the most statistically significant predictors of sales are February, August, November, and December with 3 stars, and then June, July, and September with 2 stars. You remember that in R, the star system relies on the p-value. For a p-value below 0.05, which is usually deemed statistically significant, you get a dot. Below 0.01, you get 1 star. Below 0.001, you get 2 star. And then the closer it gets to 0, you get 3 stars, which is extremely statistically significant. Now, if we look at the t-value and the sign of the coefficient, we find out that December, followed by November and February, have the strongest positive effects on sales. And as explained by Professor Glady in the videos, this mostly makes sense since a lot of people in the northern hemisphere buy chocolate for the end of the year holidays. Now, another interesting information here, would be to see the distribution of sales for each month. To see that information, you can create a box plot. Because the month variable is a factor, R will automatically represent the sales per month using box plots like this. We then add a main title, axis labels, and use the xlim argument like we did before, and we get this plot, which shows you for each month the distribution of all the sales that happened in January, no matter the year. Again, for February, March, April, etc., etc. Now, a box plot is a very interesting visual way to understand if there's a lot of variation in the sales of a particular month. For example, in December, you see that there is a lot of variation, while in July, the data is very similar from year to year. Now, how does the model perform on past data? Let's plot the actual sales as a function of time and add the sales as provided by the model. To do so, we use the plot function with time on the horizontal axis and sales on the vertical axis. Then again, we add titles and axis label that you can explore on your own time. In order to add the fitted values to the same plot, we use the lines function, where time is on the horizontal axis and the fitted values on the vertical axis. Then we set the type argument equal to L in quotes because we want a line, the col argument equal to blue in quotes because we want this line to be blue, and the LTY argument allows you to specify the type of line that you want to use, and 2 allows you to have a dashed line. Let's run the line. Now we see that the model does really well, and it also allows you to reduce a lot the uncertainty for stock management. Now, to make your plot more explicit, it would be a good idea to add a legend by using the legend function. The first argument here set equal to top left in quotes lets R know that you want your legend to be at the top left corner of the plot. We then use the C function to set the text that we want to use in order to describe our lines. Then again, in order to describe the type of lines that we want to use. And we maintain the same order for all the arguments. So the actual sales have an LTI argument set to 1 because it's a complete line, while the sales by the model have an LTI argument set equal to 2 because it's a dashed line. And then again, for the col argument, we set the actual sales equal to black and the sales by the model equal to blue. Now let's run this line. And we do have a legend here. So that's it for our fourth and last example of this module. I hope you had a good time and learned a lot. And now it's time to go and eat some chocolate for real.